Just because two PLCs are connected doesn't mean they can communicate. In this video, I'll show you why cable, ports, and protocols all have to work together, and where most people get it wrong. When working with Allen Bradley PLC systems, it's important to understand that communication happens in two layers. First, there's the electrical connection, Ethernet, DH+, DH485, or RS232. Second, there's the protocol, which is a language the PLC actually speaks. You always need both the correct physical connection and the correct protocol, or communication simply won't happen. A common mistake is assuming that if two devices share the same port, they can communicate. For example, two PLCs may both use Ethernet, but if they don't speak the same protocol, they still won't understand each other. Think of the port as the phone line, and the protocol as the language. Without a shared language, the connection alone is meaningless. Here's where this really matters in the field. If two devices both use DF1, they're typically communicating over RS232 and can talk to each other. If they're using Profibus DP, they're operating over RS485. The takeaway is simple. The hardware enables communication, but the protocol determines whether communication is possible. A protocol is simply the set of rules that devices use to exchange information. Every PLC manufacturer defines its own protocols, and Allen Bradley systems commonly use DF1, DH485, DH+, Ethernet-based protocols, and others. This is why two PLCs can be physically connected and still fail to communicate. They're not speaking the same language. Once you understand the difference between connections and protocols, troubleshooting communication issues becomes much faster and more logical.